Jakobshavn Glacier is discharging ice from the Greenland ice sheet and into the ocean at record speed. NSF-funded researchers from the University of Washington and international partners measured the dramatic speeds of the glacier in 2012 and 2013. During the summer of 2012, the glacier reached record speed of 46 meters per day, nearly 3 times what it was in the 1990s. The team believes the increased speed-up of the Jakobshavn Glacier means it's adding more and more ice to the ocean, contributing to sea level rise. The researchers believe the glacier is in an unstable state and will continue to retreat further inland in the future. Move over superglue, there's a new kind of adhesive on the block. A University of Illinois research team has created new dynamic materials that have self-healing properties and could even remove the paint from walls. Utilizing commercially available materials, the team developed a simple, inexpensive process which, when applied to an existing coating like paint, could make it self-repairable if there is a scratch or crack, and easily removable. The substance consists of soft, elastic materials made of polyurea, one of the most commonly used types of polymer found today in paints, elastics, and plastics. The polymer's self-healing properties were put to the test in a lab. After the polymer was cut or torn, the researchers pressed the 2 pieces back together and let the sample sit overnight to heal. The team found that the polymer bonded back together almost as strongly as before it was cut. The team feels this chemistry could modify existing materials and make them more dynamic, even healable. New research found that it doesn't take much time for a volcano to become active. An NSF-funded collaborative research study between Oregon State University and the University of California, Davis has shown that some volcanoes can go from dormant to active in as little as 2 months. For almost 100,000 years, magma has been sitting in cold storage at temperatures below 750 degrees Celsius, deep below the surface of Oregon's Mount Hood volcano. Adam Kent and Carrie Cooper found that when the temperature of the magma warms even 50 degrees, it can go from immobile sludge to fast-moving and liquid-rich.
The temperature that we chose was an interesting temperature volcanologically because it's a temperature at which you get, it's a temperature of the transition between a mostly liquid magma that can be mobilized and erupted and a mostly solid magma that can't.
Warming is probably the result of arrival of hot magma from deeper below the volcano, and when this mixes with the cooler magma, it can trigger eruptions. Kent says that at Mount Hood, these eruptions are typically less violent. Instead of exploding at the top, magma oozes out of the peak. Although this can still trigger destructive landslides, including mud flows called lahars, the team believes today's modern technology might be able to detect when magma is beginning to liquefy and indicate when a volcano is awakening. Researchers hope to now apply these techniques to other larger volcanoes, assisting in efforts to forecast volcanic eruptions in the future. Clemson University bioengineer Karen Berg and her NSF-funded team are advancing the fight against breast cancer. Berg's team is developing novel ways to study the complex behavior of cancer cells in breast tissue. They are building scaffolds that mimic a 3-dimensional structure of human tissue. This biofabricator machine deposits cancer cells at strategic locations inside the 3D structure, just like tumors in human flesh. Testing these structures allows Berg to pinpoint which treatments work best for patients, depending on the severity of their cancer. Karen Berg explains.
Depending on whether the person is a late-stage cancer patient or an early-stage cancer patient will make a very big difference in the type of 3-dimensional structure that we would build.
By understanding how cells function and communicate with the environment in a 3D tissue structure, Berg feels this research may one day change the way doctors treat the disease. For more information about these stories, visit us at nsf.gov. This is NSF Science Now. I'm Dina Hedley.